Okay, if you are online, please use the chat box, the chat section. I want you to say hi. If you are online, please say hi on the chat, on the live chat. Please, if you're online, say hi to the live chat so I can start. There's no time. I'm still waiting. I'm still waiting. If you are here, say hi. If you are here, say hi. Okay. I am seeing Chisomaga. Chisom Celestine. Okay. Chisomaga, you are not a science student, so I hear. But anyway, no problem. That's enough for me. So I want to start. We are doing physics today. We are doing physics today. How do I know okay. Okay. All right. And today we are going to be talking about optics. Optics. Okay, let's continue. Sorry. Okay, let's continue. Sorry. Okay. This was so optics. Optics is simply a branch of um, it's simply a branch of physics that deals with the study of light waves and its properties. Okay. Optics is simply a branch of physics that deals with the study of light waves, its properties and its application. That is what optics is all about. All right. So we have some terms we use in optics. Okay. The first term we use in optics is transparent objects. All right. Transparent objects. A transparent object is an object that can allow light to pass through it easily. All right. Transparent object is an object that can allow light to pass through it easily. All right. Now, the other term we use is what? The opposite of transparent object is opaque objects. Opaque objects. Opaque objects are objects that do not allow light to pass through them at all. I get it. Now, if you are looking at transparent objects, you're going to see objects that are behind transparent objects, and that's because light is passing through it. Now, there is a way visibility works. All right. There is a way visibility works, okay? Lights do not just incident in our eyes, all right? How do we see objects, okay? We see objects when light from a light source, all right, incidents on them, okay, that it strikes them and reflects into our eyes. That is how we see. So we see objects that are beyond transparent objects, but light can pass through those transparent objects. When light from a light source, okay, incidents on objects, all right, they reflect, and as they are reflecting, they are passing through that transparent object into our eyes, and that's why we can see those objects behind the transparent object. So that's because light can pass through transparent objects. But light cannot pass through translucent opaque objects, okay? Light cannot pass through opaque objects, right? When light tries to pass through, the light, since it cannot pass through, it is reflected instead. So if this is an opaque object, if light from the sun, okay, comes, all right, since it cannot pass through, what happens? It bounces off, that is, it reflects. Do you understand? So that's basically what an opaque object does, okay? An opaque object is an object that light cannot pass through. I guess it. Now, a translucent object is the kind of intermediate between what? A transparent object and an opaque object. All right? A translucent object, translucent. In a translucent object, light can what? Can pass through it, but not easily. I get it. Light can pass through it, but not easily. In the sense that, all right, when light incidents on it, only a few rays, only a few amounts of the light will pass through. The rest will be reflected. Am I communicating? So, which means it lies between an opaque object and what? And a transparent object. You understand? So you can see objects that are at the back of a translucent object, but it will be very blurry. Are you getting it? An example of a translucent object, a practical example of a translucent object, is a paper stained with oil. Okay? When a paper has been stained with oil, is an example of what? Of a translucent object. Am I making sense? Then we have what called luminous objects. Luminous objects. Now, luminous objects are objects that can produce light on their own. Okay, objects that can produce light on their own. Okay, they are called luminous objects. Okay, an example of a luminous object is the sun, our bulb, fireflies, and so many other things. Okay, that can produce light on their own. That's what we call luminous objects. Another term we use in optics is you have a non-luminous objects. Non-luminous objects. Non-luminous objects are objects that can produce light but not on their own. Okay, they are objects that they produce light but not on their own. Okay, as a matter of fact, their light production is as a result of what? Reflection of what? Of light from a luminous object on them. I get it. A practical example of a non-luminous object is the moon. The moon does not produce light of its own. The light produced by the moon is not its own. Okay, it is a light that is what? That is from the sun. Okay, the light from the sun is incident on it and reflects. Okay, that is how the moon produces light. Do you understand? So I'm still getting the hang of this live. If you have a question, you put it on the live chat, okay? I will see it eventually, all right? And then I'll answer it, all right, subsequently. So let's move on. So that is that about non-luminous objects. Non-luminous objects, they produce light, but not on their own. Are you following? So that's basically that. So all these things, the accumulation of all these things forms what we call shadow. What is shadow? Shadow is a region where light cannot get to. A shadow is a region where light cannot get to. Am I communicating? Okay, it's a region where light cannot get to. And that is because an opaque object, you know, I told you an opaque object, light cannot pass through it. Okay, I am an example of an opaque object. Okay, a bag is an example of an opaque object. A chair is an example of an opaque object. I guess it. Any object at all that light cannot pass through, I guess it, is what is called what? An opaque object. Am I communicating? So when an opaque object is in a part of a traveling light, I get it. Alright? You see that what that opaque object will block off the light. So the light will incident on it and it will reflect. When the light reflects, I understand, at the back of that place, okay, a shadow is cast. That shadow now, the light cannot get to it because why? The shadow is what is obstructing it. Am I repeating it? So that is how basically it is. Okay. Let's say okay. So let's say we have a scenario where this is an object, all right, and the object is on the floor. So light is coming from here. Beam of light, different beams of light are coming from here. All right. So you can see that when this light comes here, this one will move right to this point, to this place. But this one now will be able to this ray of light will not be able to penetrate because of this the ray of this object. So this object, all right, why this place got light, this region now will not be getting light because why? This light rays are being blocked off. Are you seeing it? All right, this light rays is being blocked off. So because of that, the shape of this one, a shadow is cast here, a dark part is cast here, which will be in the shape of this one, of this object. Do you understand? Because light cannot get to this point. Do you understand? That is basically what shadow. All right. So what are the consequences of shadow? The first consequence of shadow is what? Is eclipse. 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 What are eclipses? What are eclipses? Now, eclipse is a sudden cut-off of light. I guess it's from a planetary body. Am I communicating? That is how simply I can put it. Okay, the sudden cut-off of light from what? From a planetary body, owing to the fact that what? The shadow of another planetary body, okay, is being cast on that planetary body. Am I communicating? For example, let's say this is a planetary body, okay, that is receiving what? Light. I guess it from maybe the sun or the moon, as the case may be. Okay, it is receiving light from the sun, and the light ray is moving, okay, towards the what? The planet or planetary body. I guess it. So this place is getting a supply of light. I guess it. All of a sudden, another planet, okay, now comes and what? And move in the what? In the path of the what? Of the traveling light to that other planet. And since the planet is what? Is opaque, okay? It will now start reflecting these lights. I understand. Do you understand? It will now start reflecting them backwards. Do you understand? So because of this, light can no longer get to this planet. So the shadow of this planet now is not cast on this shadow. Do you understand? So light has been suddenly cut off from this planet, okay? That is what we call what? Eclipse. That is what we call eclipse. I hope you understand. Okay. Now we have two types of what? Eclipses, basically. Alright? We have the two types of eclipses, okay? We have the lunar eclipse and we have the annular eclipse. Alright? We have the lunar eclipse and we have the what? Annular eclipse. Sorry, we have the lunar eclipse and the solar eclipse. What am I saying? We have the lunar eclipse and what? And the solar eclipse. The solar eclipse is also called what? The eclipse of the sun. While the lunar eclipse is also called the eclipse of the moon. I guess the solar eclipse occurs when the moon comes in between what? The sun and the what? And the earth. When the moon comes in between what? The sun and the earth. What happens is this, okay? Let's say look at the earth and look at the sun. I guess then the moon now moves between the sun, between the sun and the earth. I guess okay? We will have what? A solid color of light. Okay? The moon will cut off the light from the sun to the earth. I guess alright? It will not be supplying the earth with its own light. However, since the light from the sun has been suddenly cut off, that is what we call eclipse. We call it solar eclipse, which is the eclipse of the sun. Are you getting it? All right. So of course, the eclipse of the moon is also called the lunar eclipse. Of course, when the Earth comes in between the sun and the moon. Okay, your WAEC and your JAM, these questions are not common. So I'm trying to move ahead. So I will move to the main material. Are you getting it? Now that is about that. All right. Moving ahead, we are going to the pinhole camera. The pinhole camera. If you don't understand, if there's anything you don't understand, this immediately I finish this live, I end the live, it will be uploaded into the channel. So just go on the channel and rewatch the video again. Every section you don't understand, just rewatch it, it will be very easy. So that's just it. So we're going to yes, we are still doing optics. We're going to pinhole camera. The pinhole camera is what? The box. The internal section of the box is painted black. It is painted black, so that the inside is dark. Okay, the box is typically a cube. It's like this. Alright? So inside will be painted black. I guess it. Then they will create on one surface, they will create a hole, which is the size of a pin. So most likely they use the pin to puncture the hole at the center of one of the face. I get it. Then directly opposite that face, let's say this is how it is. Directly opposite that face, there is a photographic film. Directly opposite it. Do you understand? Okay, so the light from the rays will be directly pointing at what? At the opposite film, just directly facing it. Am I communicating? That is how it is done. I don't know if I'm making sense. So it's as simple as that. Okay. So the pinhole is just at one face. That in the face that is facing that where the pinhole is, there is a photographic film that is there. So any object that is appearing here, somewhere here, I guess the light rays from the object, of course, the light rays from the sun or any light source will move towards the what? Towards the object, strike the object, I guess and then reflect into the pinhole. It will reflect in this manner into the pinhole like this, and then from the bottom like this. I follow you. So the object, this object now, the image of the object is going to be formed on this one, on this photographic film, in an inverted form. I follow you. It will be inverted. Let me make it bigger so that you will see what is going on. Let me make it bigger so that you see what is going on. This is how it is. This is how it is. So a pinhole is here. I get it. This face now that is facing the pinhole. Look at it. This face that is directly opposite the pinhole, there will be what? A photographic film, rectangular, this thing, whatever. So this object now, when the light is moving from this object down here, to pass through the pinhole to the photographic film, from the bottom it will pass through like this. So you see, since the head here is coming like this, and the bottom here is coming like this, we have an inverted image in this form. Do you understand? So the image will be inverted. It will be real, it will be inverted. Am I communicating? So as time goes on, I'll be telling you what it means for something to be real and what for it to be what? For it to be virtual. Because the opposite of real, a real image is what? Is a virtual image. Am I making sense at all? So that is basically it. Alright? The image of the form is what? Is real. Now, the further the pinhole is from the object, the blurring, the more blurry the image that will be formed on the photographic film. Okay, and the closer I guess the sharper. I guess the closer the sharper. Now, from the pinhole to the object is called the object distance. We use U to represent it. From the pinhole to the object is called what? The object distance. We use U to represent it. Now, from the pinhole, okay, to the image, that is to the photographic film, is the image distance. That is from here to here, which will be as in the width of the camera. You know this now, this is a face, and this is a face. So from here to here is actually from here to here. I get it. You understand? If you understand how a box is built, okay? You understand? From the pinhole, which is on this one of the surface, to the photographic film, is the same thing as the width of the camera. Do you understand? So sometimes they will use width of camera, and sometimes they will use width of camera. In some questions, they will use width of camera. In some questions, they will use image distance. It's still the same thing. The image distance is actually from what? From the hole to the what? To the object, to the image, sorry, and it's the photographic film. Which happens in the pinhole camera, which it happens to be what? The width of the camera, which is from here to here. It will be V. Do you understand? So that's basically that. Alright? So if you have a question, please ask. If you have a question, ask on the chat box. I will view it later and I will answer all questions. Alright? I cannot see the chat there from here. I don't know why I cannot see it. But when I finish the class, I will check the video, I will check everything that you will ask, and then I will make another video answering each and every question. You understand? So that is basically it. Okay, so the object design is from the object, I guess it, to the what? To the pinhole, I guess it. So that is basically it. So if they tell you the object distance is 30 centimeters, that means the object is standing 30 centimeters from the pinhole. I get it? Standing 30 centimeters from the pinhole. If they tell you that the object distance is 100 centimeters, that means the object whatsoever that they require the image is standing 100 centimeters from the pinhole. Then we now have the image distance, which is from the pinhole to where the image is. From the pinhole to where the image is. So from the pinhole to the image, is usually the width of the camera. Okay, because of course the pinhole is on one surface, and the camera is on the surface directly opposite it. So you understand? So that's the thing. So we have a magnification of the image. Magnification of the image. The magnification of an image is what? Is the distance. Okay? It is the distance from what? It is how big, how large the object is. The image is. Okay? How large the image, that is for magnification of the image. How large is the image? How large is the image? Do you understand? So when the image is larger than the object, we say the image is magnified. I guess it means when the image is larger than the object, we say what? The image is magnified. When the image is smaller than the object, we say the what? The image is diminished. Am I communicating? But when they are of the same size, what happens? See what? Same size as objects. Am I communicating? So it's as simple as that, okay? Magnification of the image. And it is noted as M, okay? The magnification is always equal to what? The image distance all over the object distance. I guess the image distance all over the object distance. So if, for example, the width of the camera is 10 centimeters and the object is standing maybe 40 centimeters from the what? From the pinhole camera. So you observe that what the magnification of what? The image distance over what? The object distance. That will be what? 10 divided by what? By 40. Do you understand? Which will be 1 over 4 or 0.25. You understand? Now magnification have no units. Okay? Do you understand? Magnification have no units. Okay, the magnification, because why? This is distance, this is distance. So the centimeter advances centimeter. I get it to make it what a dimensionless what unit or a dimensionless quantity. Do you understand? So it has no units at all. So magnification is what V over U. Also, magnification is also the image height all over the what the object height. That is the image height all over object height. That is the height of the image divided by the height of the object. That is what we call the magnification. You understand? You get it? So in some terms, they tell you size of image or size of object. All of them, they are in terms of the height. That is, from the bottom, how high is the top of the object to the bottom of the object, and how high is the top of the what image is the top of, bottom of the image. So that's what I say. Image height all about object height. So that means we can say what magnification is equal to image height all over object height, and it's equal to what image distance all over object distance. Any of these you can use them for solving question. So that is basically that. Last question, ask. Okay, let's go into some calculations. Let me give some examples of calculations that we have. Let's see a question. An object 14-meter high is placed 10 centimeter, 14 centimeter high, is placed 10 centimeter from a pinhole camera whose width is 7 centimeter. Calculate the eye magnification of the image produced. Okay, the height, or let me just say the size of the image. Now look at that. With this, you're going to answer it. Okay, let's continue. An object 14 centimeter high is placed 10 centimeter from a pinhole camera whose width is 7 centimeter. Calculate the eye magnification of the image produced. Size of the image. Alright, now how do you do this? It's very, very easy. Alright, the first thing, an object is 40 centimeter high. That means the height of the object is what? 14 centimeter. So that means object height is what? 14 centimeter. Alright, then it said it's placed 10 centimeter from a pinhole camera. That means the object distance, which is U. U is what? 10 centimeter. Alright. They said the width of the camera is what? Is 7 centimeter. They said pinhole camera whose width is 7 centimeter. That means the width of the camera, which happens to be the image distance, V, is what? Is 7 centimeters. Alright? So we find what? Magnification, first of all. We are looking for M, and then we are looking for what? Size of the image, that is image height. Okay, so it's actually easy to do something like this. How do you do it? It's very simple. Alright, we use this formula. Okay, so now first of all, we are looking for what? For the magnification. If you observe, we have the object distance and the image distance. So we use those. That will be m equal to v over u. M equal to v over u. That's m will now be equal to what? V is what? V is 7 centimeters all over u. U is what? U is 10 centimeters. So of course, you know now the units will cancel the units. So that will be, we are left with m equals to 7 over 10, which is 0.7. So that is the magnification basically. Alright? M is what? 0.7. So to get the second thing, which is the image height. The image height, how do you get it? You know that what magnification is not what? Image height over object height. And we've already gotten the magnification to be 0.7. That would be 0.7 is equal to image height, which is what we're looking for. Let's say it is x. All over object height. Object height in this case is object height is 14. Alright? So what do? You cross multiply. If you cross multiply, you have what? X times 1 is equal to what? 0.7 times 14. So x is equal to 0.7 times 14 will give us I think 1 point or something. Okay, 14 times 0.7. 7 times 4 is 29 is carrying 2, 9, 0, 0. That's 890. So that will be 9.8. 9.8 was centimeters. So that means what the image height was 9.8 centimeters. That's the answer. So if you have a question, you put it on the chat box and let's go ahead. So that is how you solve a question like this. Alright? That is how you solve a question like this. I'm going to do more questions. The video is a bit dull because there's no light. So we continue, we move ahead. I believe that should have been taken. If you've not gotten it, always remember that you can always come back to the channel to rewatch it again. So rewatch it and understand it at your own pace anytime you want to. Alright? So that's that. Another question is this. Please be patient. Yes. Another question is this. A 20 centimeter high image of magnification zero point 0.5 was formed when an object is placed 12 centimeters from a pinhole camera. Calculate the width of the camera. Calculate the width of the camera. Hence, determine the height of the object. A 20 centimeter high image of magnification 0.5 was formed when an object is placed 12 centimeters from a pinhole camera. Calculate the width of the camera. Hence, determine the height of the object. Hence, determine the height of the object. So how do we solve this? It's the same set of formula you use. All right, let's continue. So we have that, all right? So, a 20 centimeter high object, that means that the height of, a 20 centimeter high image, that means the height of the image. Image height is what? 20 centimeters. Of magnification 0.5. M is what? 0.5. Was formed when an object is placed 12 centimeters. That is the object distance, which is u, is 12 centimeters. Alright? From a pinhole camera. Calculate the width of the camera. We are looking for the width of the camera, which is the same as image distance. Remember, which is the same as image distance, the width of the camera. Hence, determine the height of the image. So, height of the object, object height. So, of course, we are looking for V first, right? So, the first thing we can use is M equal to V over U. Because we have the magnification and we have the object distance. So, we can use this formula to find our image distance. So, the magnification is what? 0.5 is equal to object distance image distance, that's what I'm looking for. All over the object distance. What's the object distance here? 12, right? So you put your 12. So you cross multiply. If you cross multiply, you have V times 1 is equal to 0.5 times 12. So V is equal to 0.5 times 12 is what? Is 6 centimeters. So the image distance is what? Is 6 centimeters, which means the width of the camera is what? Is 6 centimeters. The width of the camera is 6 centimeters. So from here, we have they say we should look for what? The object height. So for the object height, what do you have? The object height we use our what? M equal to what? Image height over object height. Since we already have image height already, 20 centimeters. So our umbrella is what? 0.5 is equal to image height is 20 centimeters, right? All over object height. What's the object height? The object height is what I'm looking for. Let's say that one is x. Okay? So if we do that, we cross multiply. If we cross multiply, we have 0.5 times x is equal to 1 times 20. That is 0.5x is equal to what? 20. So x is equal to what? 20 over what? 0.5. That is if you divide both sides by 0.5. Okay? Okay? So from there, x will now be equal to what? 40 centimeters. So our object height is 40 centimeters. If you have a question, you ask. Ask it on the chat box. Ask questions, please, if you have one. Ask questions. So we can move ahead. So that was that about that. We are going to solve more questions eventually, but let's continue. All right. So, and that's that. If you have a question, you can ask it. If I finish this class, or maybe you are listening to this, class when we are not doing the live. Maybe you are opportunity to come across it on YouTube, or possibly you click on the link when we are done, and you are watching this when we are done, and you cannot ask the question live. Please just go to the community. The community, once you are a subscriber, you can post on the community. On the YouTube community, it's there on the channel. You can post there. So you can ask any questions on the community once you are a subscriber. Ask any questions, and when I see them, I will be able to reply your questions. I will treat everybody's question. All right. So please be involved. JAM 2026 is coming up in April. All right, in April. So there's really no time. You need to study. As I'm teaching this, okay, you learn and then you go to your past questions. You go to your textbook. If you have all inclusive calculations in physics, all right, or you have science, physics, biology, you'll be able to see questions, a lot of it. Solve as many questions, and anyone you cannot solve, you bring it to the community. All right, you post it there, and then we'll be able to answer it for you. All right, I will do as many videos as possible answering questions that have been asked in the community. So please endeavor to be involved, so that make use of this, so that your JAM score will be very, very high. Very, very high. If you know these classes very well, you will be able to score very high in your JAM. Very, very important. You will be able to score very high in your JAM. You follow these classes very well. All right. So let's continue. We move to beam of light and ray of light. Beam of light and ray of light. light and ray of light. I want some of my classes in class. So ray of light and beam of light. Alright? Now, the ray of light is a path where light travels. It's a path through which light travels. I understand. The path provided for the traveling of light of light. Okay, the path provided for the traveling of light is what we call ray of light, and it is represented by a straight line with an arrowhead. The arrowhead is what is indicating the direction where the light is traveling towards. The direction of travel of light. I get it. And that is what that is ray of light. Alright? You understand? Now, a collection of rays of light. A collection of rays of light is what we call beam of light. I get it. The collection of rays of light is what we call beam of light. So we have rays of light, we have beam of light. We have rays of light, and then we have a beam of light. The rays are the path where the light passes through. Now, when we have more than one ray, okay, we have a beam. Alright? Now, we have three types of beam of light. There are three types of beam of light. Okay, we have the parallel beam, we have the convergent beam, and then we have the divergent beam. I repeat, there are three types of beams of light. Okay, we have the parallel beam, we have the convergent beam, and then we have the divergent beam. Alright? The parallel beam, alright, consists of rays of light that are parallel to one another. Am I completing? It consists of rays of light. In a parallel beam, the rays of light are parallel to one another. That means they don't meet. Like this. This is a parallel beam. This is a parallel beam. That is a parallel beam. Alright? A parallel beam is a beam in which all the rays of light are parallel to one another. Alright? Now, we have what we call convergent beam. In a convergent beam, all the rays of light are moving towards a point. All the rays of light are moving towards a point. Like they are coming together. The word converge. To come together to a point. I get it. So a convergent beam is a kind of beam in which all the rays of light are moving towards a point. Like this. It's like they are converging towards a point. This is what called a convergent beam. I get it. A convergent beam. Okay, they are moving towards a point. Then we have what called a divergent beam, in which is the opposite of convergent beam. Okay, alright? It is a kind of beam in which all the rays of light are moving away from a point. They are moving away from a point, like this. Like they are moving away from a point. That's what we call a divergent beam. Alright? Our torchlights produce parallel beam. Our torchlight produces parallel beam. While our electric bulb produces divergent beam. Alright? Our electric bulb produces what? Divergent beam. While our torchlight produces what? Parallel beam. Alright? So moving ahead, because I want to just spend 1 hour. We wasted time today before we started. It's supposed to be 2 hours, but subsequent class will be 2 hours, like tomorrow class. Our tomorrow class takes place from 2 to 4 in the afternoon. Please stay close. And be punctual, so you don't miss anything. So we're going to reflection of light. Reflection of light. Reflection of reflection of light. What is reflection? Now, reflection is simply the sudden change in the direction of light when it's incident on what? On a surface, on an object through which it cannot pass. Alright? Alright? I repeat. Reflection of light is the what? Is the sudden change in the direction of light when it strikes or it incidents on an object through which it cannot pass. Please forgive the how dark this place is. There's no light and it's like the rain wants to fall, so everywhere is kind of blurry. But I'll fix this before the next class. So, reflection of light is a sudden change in the direction of light when it strikes an obstacle through which it cannot pass. Now, before I move on to the reflection of light, there's what called rectilinear propagation of light. Rectilinear propagation of light. The rectilinear propagation of light is the phenomenon that shows that light travels on a straight line. The rectilinear propagation of light is the phenomenon that shows that light travels on a straight line. That is what we call rectilinear propagation of light. It's a phenomenon that shows that what? That light travels on a straight line. Light travels on a straight line. So, being that light travels on a straight line, as it is moving on a straight line towards an opaque object, knowing an opaque object cannot pass. So, as it's moving towards an opaque object, what happens? It strikes it. Since it cannot pass, what happens? It bounces off and reflects. And when forgetting, it bounces off and reflects. The ray that is approaching this opaque object is called the reflecting surface. It is called the reflecting surface. It is called the reflecting surface. This opaque object. Okay, it is called the reflecting surface. Or we can call it plane reflector. We can call it plane reflector. Plane reflector. It is called the reflecting surface or plane reflector. Reflecting surface or plane reflector. That is the surface, the object that reflects the light. I guess it. So the ray that is approaching the reflecting surface is called the incident ray. It's called the incident ray. This one, this ray, is called the incident ray. I guess it. Why? After reflection, the ray that is bouncing off, I guess it from the reflecting surface, is called the reflected ray. It's called the reflected ray. Okay? The ray that is approaching the reflecting surface is called the what? The incident ray. Why the ray that reflects, that is emanating from the point of incidence, I guess it, is called what? The reflected ray. Okay? I can put an imaginary line that is perpendicular or at right angle to the reflecting surface. I guess it, that is at 90 degrees. That is the angle between this imaginary line and the reflecting surface is 90 degrees. 90 degrees. Alright? So that is perpendicular. This line, this imaginary line I just drew is called the normal. It's called the normal. Okay? The normal must be at right angle to the what? To the reflecting surface. Am I making sense at all? So you see it, okay? The angle between the incident ray and the normal is called the angle of incidence and is denoted as I. The angle between the incident ray and the normal is called the angle of incidence and we represent it using I. The angle between the incident ray and the normal is called the what? The angle of incidence and we use I to represent it. While the angle between the reflected ray and the normal is called the angle of reflection. We call it R. We call it R. The angle between what? The normal and the reflected ray is called what? The angle of reflection, which is R. While the angle between the incident ray and the normal is called what? The angle of incidence. Okay, which you use what? As I. Okay, let's continue. So, angle of reflection, angle of incidence, incident ray, reflected ray, normal, and reflect the plane reflector or reflecting surface. Now, this angle between the angle of incidence and the reflecting surface, or the angle of reflection and the reflecting surface, we call that angle of glance. We call that what? Angle of glance. So, no, we don't need it at this level. At O level or jam level, you don't need the angle of glance. Okay? We call it glancing angle or angle of glance. Alright? So now reflection has two laws. There are two laws of reflection. Alright? There are two laws of reflection. The first law states that the incident ray, the normal, and the reflected ray all lies on the same plane. That is, they all lie on the same flat surface. I get it, okay, at the point of what? At the point of incidence. That is what the law states, okay? Alright? The first law of reflection states that the incident ray, the normal, and the reflected ray all lies on the same plane at the point of incidence. They all lie on the same plane at the point of incidence. That is what the law states. The first law of reflection states that what? The angle of incidence, the incident ray, the reflected ray, and the normal all lies on the same plane at the point of incidence. Alright? That is what it states. Now, the second law of reflection states that the angle of incidence is always equal to the angle of reflection. Sorry. The angle of incidence is always equal to what? It's always equal to the angle of reflection. That is what the law states, okay? The angle of incidence is always equal to the angle of reflection. That means this angle is always equal to this angle. So if this angle is 50 degrees, this angle will be 50 degrees. If this angle is 30 degrees, this angle will be 30 degrees. If this angle is 20 degrees, this angle will be 20 degrees. That is what the angle of incidence is always equal to the angle of what? Reflection. Alright? It's almost 1 hour. Alright? Before we end the class, let's talk about types of reflection. We have basically two types of reflection. We have regular reflection and irregular reflection. Regular reflection and irregular reflection, also called diffuse reflection. Diffuse reflection. Regular reflection occurs when a beam of light, all the rays of light in a beam of light reflects at the same angle. Alright? They all reflect at the same angle. Alright? That's regularly. That is, parallel rays of light approach a surface. And after reflection, all of them, the reflected ray, all of them, they are still parallel. They are still parallel. That means they reflect regularly like this. You have a parallel beam of light that approaches it. And after reflection, all of them reflect at the same angle like this. In the sense that even their reflected ray will be parallel to each other, to one another. I guess this is an example of regular reflection. Okay? Okay, and this occurs when parallel beam incident on a smooth surface. When parallel beam incident on a smooth surface, when the surface is smooth. But when it is rough, we have diffuse or irregular reflection like this. Sorry. Okay, so it moves, let's say 5 of light is approaching, I guess reflecting surface. But then because of the slope, they are not really smooth, okay? This one might just move like this, I guess this one will move like this, right? This one will now move like this. So it's like, it is irregular because the surface is not smooth. That is irregular reflection. In our next class, we are going to talk about plane mirrors and curved mirrors. Alright? So that is it. If you have a question, put in the chat box. Alright, tomorrow we'll be doing chemistry. Alright, tomorrow we'll be doing chemistry. And make sure you are available. If you have not subscribed, please subscribe so that YouTube will suggest this video to more people that need this kind of knowledge. If you're writing JAM, you're writing WAEC, this knowledge is needed. Very, very important. I'm going to be treating much. For now, we're doing only weekends. But very soon, I will add further days where we do